Welcome to the Gridwise Architecture Council's video library. The following presentation by Paul D. Martini is entitled Distributed Resource Utilization and Coordination and was presented to the Gridwise Architecture Council on May 14th, 2025. Welcome, Paul.
Well, thanks for the opportunity to share a few thoughts on some of the work that we've been doing over the last year or so for the Office of Electricity, but also some additional work that I've been involved in with supporting several utilities and others. Like I mentioned, some of the work that I've been doing and technical assistance for some of the state commissions, including, as I mentioned, New York and their Grid of the Future effort. And so what I'm going to touch on today is really three areas. So what's happening with distribution grid needs, and as more trend, information, distribution flexibility service provision. So how are people thinking about sourcing and orchestrating flexibility services from distributed resources and how that is evolving, and then thinking about how we develop resource portfolio development for distribution in particular. It's a little different than bulk system. Obviously, you don't have the law of large numbers at play in distribution. So how do we think about managing that effectively and reliably? And then a few thoughts to share on operational coordination as that's evolving, the sort of TSO, DSO, service provider, customer coordination that is developing further, but some thoughts on that to kick around with you all and hopefully spur some conversation. So in terms of distribution grid needs, there was a Berkeley Lab report that came out at the end of last year tracking what's happening with retail rates across the U.S. on average, as well as where spending and spending trends have been over the last 5-6 years. So what I was describing here is trends that are happening with electricity rates, and in particular where capital expenditures are going. As you can see on the left, hopefully that you've seen. So the light blue line is the retail sales, which have been relatively flat across the U.S. Now we know that in certain areas of the U.S. with data centers coming online, some of the load growth has been growing, and particularly this ends at end of 23, and we've seen a big uptake in 24 and into 25. But across the U.S. it hasn't really changed that much. However, if we look at the cost, retail prices have been increasing dramatically above the rate of inflation over the last years, and that's continued over the last year or two, and projected by several utilities in terms of their growth, in terms of capital expenditures and the implication on rates. And this is not due to wholesale power prices. This is due to infrastructure capital investment. And as you can see on the right-hand side, the majority of the capital expenditures on average in the U.S. by utilities is distribution. So 44% of capital expenditures are distribution. Transmission is only 19%, and generation is also only 25%. That's a pretty big change from 20 years ago, certainly. But this trend on distribution expenditure growth is not only what we're showing here for the last 4 or 5 years, but it's also projected to continue. Several utilities that I'm aware of are projecting in the neighborhood of 8% average growth in distribution expenditures over the next 10 years. So we're seeing pretty dramatic expansion in projected capital expenditures. And as you can see down at the bottom in the box, according to EEI, the allocation of capital is primarily on resilience-related investments. So 37% of the capital that's being expended is is around adaptation, hardening, and resilience. 28% is aging asset replacement, which also addresses safety and reliability. Capacity expansion, which is the one that we tend to focus on for flexibility services, is 28% of the capital being expended, and other areas are 7%. So no surprise that across the U.S. we're starting to see more and more utilities, whether through a regulatory requirement and or on their own, in terms of looking at whether they are looking to deploy technology themselves through their own programs or through contracted services. In some cases, for example, in Texas, the two large investor-owned utilities have been pursuing contracted battery, front-of-the-meter battery solutions. But we see a fair amount of the U.S. looking at options to leverage distributed resources in some form to help mitigate distribution level capacity expenditures. Now, the thing to keep in mind is that the way that, in many cases, what folks are looking at is a way to manage that expenditure, both in terms of potential avoidance, but primarily around deferred and deferral of capital, and so managing capital in a way that smooths out that expansion and some of the other issues, perhaps, as we've seen in California and a few other places, around resilience and thinking about remote microgrids, for example. So I'm including microgrids, utility-sided microgrids as part of the mix, whether that's a community microgrid or remote microgrid or some form like that, as opposed to customer-sided microgrids as part of the solution set. So we're seeing a wider set of. Okay. Okay, great. Thank you. So this just illustrates what I was trying to describe, which is an expanded use of DER services for distribution grid needs specifically. Now, obviously, if we were looking at bulk system, a number of other states would come into play, but focus specifically on this issue at distribution and the rising cost of retail rates and the implication that rising and growing capital expenditures on distribution. There's this recognition both from commissions to manage customer affordability, stakeholders, and the utilities themselves realize that they need to manage the capital and remain reasonably, customer affordability is an issue that they need to address as part of their capital planning. And part of that mix is looking at alternatives such as flexible DER services as part of that. And as I said, this is a combination of what they may contract with third parties, whether it's behind the meter, front of the meter, or their own programs that they may do through demand side management and other kinds of approaches that they're using, which I'll talk about in a second or two. But anyway, what we're seeing is a fairly expansive growth in exploration and pursuit of distribution level services. Next slide, please. Now, the thing, as I mentioned at the outset, is different at distribution than bulk system, is the granularity that's required to mitigate the issues. So, on the right is just a quick shot of a hosting capacity map that Liberty Utilities has, and just to illustrate the point that, as you all know, on a distribution feeder, if we're talking about radial systems, which is the predominant architecture for most utilities, you will have a branching scheme that you can have constraints at various points on that, both in terms of the main line and sections of the main line, as well as the laterals and the like. And so you can end up with this very complex set of constraints as illustrated in red, or growing ones in yellow, versus those that have capacity, no constraints, that are represented in green. So this is a sort of challenge that utilities are increasingly looking at to try and manage particularly as capacity expansion is both for load growth, but also the potential to integrate more resources. And as I'm sure many are aware, a lot of states are still continue to pursue a lot of distributed resources, particularly distributed solar and storage, as well, and in the form of community solar and storage. So some of that is on the primary, higher voltage primary distribution, but subtransmission is also an issue that comes into play. And that pursuit is because in many cases, the commissions aren't seeing the transmission development happening fast enough to for larger scale, plus siting issues for larger scale renewables and other generation. And so, the policies around how to leverage more distributed resources to meet those resource objectives and the like that states are pursuing. There are also some resilience aspects that folks are looking at with respect to more distributed batteries as part of the mix as well. But the thing to keep in mind is that, this complexity, if we look to the next slide and sort of think about what's driving the current sort of challenges around constraints. Next slide, please. Thank you. Is that, as we have more distributed resources, whether it's EVs, batteries, solar, and the like, we will have quite different power flows happening on the distribution system in various directions. I mean, we've talked about multi-directional power flows on distribution feeders and networks for some time, but this is now becoming a reality as a result of the adoption of more distributed resources in electric vehicles. So the challenges that are sort of identified here in terms of the red areas are, essentially reflected in that prior hosting capacity map, and the yellow and the green and so on. So as we think about managing the constraints, we need to understand these power flows, and then we need to think about what are the solution set in terms of being able to address these constraints without having to do a physical upgrade. So this is part of the challenge. So we're definitely moving well beyond the substation level, which is kind of where the focus was 10 years ago or so. And now we're much more into a granular look on the main line and in several cases on laterals in terms of thinking about how to manage this, these challenges. Next slide, please. So one of the other things that's important to consider is that when we think about the constraint management, related to power flows and the current capability on various distribution assets, conductors and the like, and transformers, is that those peaks on distribution may or may not be aligned with the overall system peak. So on the left-hand side, look at load curves on, say, a distribution as represented in gray that are convergent with the system peak. And so to the extent that you create solutions for distribution, you're going to get some added benefit for the bulk power system at the same time. However, for many circuits in a utilities service area, you may have quite divergent needs. And so as represented in the gray would be the distribution peak, and then you see the system peak in the blue. So you can have this divergence between needs on the distribution and the bulk power system, where the benefits aren't additive necessarily in terms of the use of the service on distribution and what the impact is on transmission system. So the kind of analysis that's needed here is much more of a bottom-up analysis that utilities are undertaking now to better understand this dynamic, where this exists in their system, and then thinking about how to optimize the use of distributed resources, both at distribution first, given that that's the largest capital impact, and then by extension, what the value is in the bulk power system. And so starting to have much more and more granular analysis to really sort this out, and then think about the implications for coordination and design of the various sourcing solutions and orchestration mechanisms that would be involved. Next slide, please. So that kind of sets up the challenge that we're looking at. And as I mentioned, then really what we'll touch on next is, so how are people thinking about provisioning flexibility services and from DER and various service providers, and then how do we develop portfolios around that and the considerations that folks are undertaking towards that end. Next slide, please. So as we think about the various approaches that people are taking to for sourcing, and I'm going to use the term sourcing method and orchestration mechanisms, they go hand in hand. First, the sourcing methods are the means by which you source the service that you're looking to utilize for a particular grid need, whether that's thermal or voltage or whatever it might be. And the orchestration mechanism, which I'll touch on next, is the means by which you operate the system, you animate the response that you're looking for. So in the first case, really what we're talking about here is how do we think about the various means by which people are sourcing these solutions, either individually from a consumer or in aggregate through a service provider, or in some cases, more directly by the utility themselves through some means. And in this realm, we're really talking about pricing programs, procurements, and various market structures that folks are pursuing both in the U.S. and internationally to accomplish this. One of the things that Samir Sikar at ICF and I were kicking around was this idea of trying to understand what really works well for both utilities performance and ratepayers value and the certainty of that performance from the various using these various methods for getting results. And these methods include any sort of performance requirements that are embedded in a tariff or in a program, say pay for performance under a program, or in a contractual setting with respect to any penalties or non-performance issues that are addressed in the terms and conditions. So thinking about how these various means by which you source this, how effective they are. So that's on the vertical axis. On the horizontal axis, we're looking at what the value is that the customer, who's actually the service provider, and the aggregator who is aggregating these various DER from customers, their value and certainty. So what's in it for them? Is this meaningful enough? Is this a financially viable option and approach to be used? And so this forms the two axes when we think about how effective these various sourcing options are. And this is essentially a snapshot of where we are today, if you will, to look at these various means by which people are pursuing. So whether we're talking about a retail TOU rate, a traditional DSM program, a NEM tariff, NWA procurement, these new local flexibility markets that are emerging. They've been established in Europe and the UK, but are emerging in the US and Canada. Local constraint markets that are starting to emerge in the UK. Distributed capacity procurement, which is a concept that sort of originated with Green Mountain Power, and then Liberty Utilities has a version. Excel just announced a version of this as well. And then VPP standard offer tariff, which was proposed last summer by a group of aggregators and solar developers. So there's a variety of ways that people are thinking about how to attract resources through a NWA is non-wires alternative, or otherwise known as non-wires services procurement. And NEM is net energy metering. Those are the tariffs that have been around for quite some time at retail level for individual customers to incentivize the adoption of solar.
There's a question in the room too, Paul.
Yeah.
Yeah. So Paul, this is a really interesting slide. I'm just curious how how this slide is reconciled with the increasing marginal costs that we've shown, like the sharp increase in marginal costs that you showed a few slides ago. If those costs aren't properly being captured in the way that we're valuing these services, how can this slide make sense in practice, right? So like we have methods in the regulatory space to economically evaluate cost effectiveness of DERs and non-wires alternatives. But those, I think the consensus that this group may share, may not, is that those are woefully inadequate. And if you're using that to assign values here in terms of what's helpful and not, this slide doesn't. What's the impact of this slide in practice?
Can I go off of that a little bit? Because I don't think commissions are understanding the value of these technologies and the methods well. I mean, there's been no definitive way of determining the value of, distributed capacity procurement, stuff like that, and what the constraints actually cost the system. So are there any information on how to do this for a commission?
Yeah, I mean, I just asked that because I spent like 80 hours working with like lawyers on this topic over the last like 5 days. So it's like fresh in my mind. I don't know if anybody has a response or even if that makes sense to people. I mean, that's a pretty in the weeds kind of thing.
Go ahead.
Well, actually, it's not a weeds in the weeds thing. So what this slide was intended to do in the 2x2 was basically address the issue you're raising, which is, so if we're going to have effectiveness, if we need to be in the upper, right quadrant, right, in terms of being able to have scalable value, both for the ratepayer in terms of you're mitigating the distribution costs that you're trying to avoid, and you have sufficient value for participation, whether it's by the customer and any service provider that's required as an intermediary in that, and frankly, everybody else in that chain that provides that value, right? All the technologies that are required to, to help enable that we need to find solutions that get to that point, whether that's a combination of the sourcing method and then the compensation that goes with it. And so on the question of compensation, I do appreciate that, the deferred value methodology or avoided cost of distribution has been an issue in many places that people perceive that as not sufficient. To be able to do, there's a tension there with commissions and office of ratepayer advocates in many states in terms of how to think about the cost and what you're trying to mitigate or avoid, and which cost should be included or not. In some cases where you have convergent needs between bulk system and distribution, as I showed on the prior slide, then yeah, you can have additive wholesale benefits that could accrue when you initiate a response. In other cases, they're divergent. So when you use it for distribution, you're not necessarily going to get bulk system benefits. It's not absolute one way or the other. Those are just giving you some bookends to kind of talk about the spectrum that we're dealing with. But in there, we need to do much more analysis to understand what those, how that works. The other is, there's been a lot of discussion in many of the regulatory settings around societal benefits. And what I'm seeing, and maybe you're seeing this too, is that a number of commissions, because of the rate increases, are less likely to include societal benefits, because if it doesn't result in lower utility costs, then they're less inclined to include societal benefits, because otherwise it just potentially maybe increases the net cost in terms of rates for customers. So there's been a tension there about some of the societal values that might otherwise have been, previously thought about or included. So I'm not an advocate on one way or the other. I'm just sharing like what I see in terms of the conversations that I'm in and we've been studying. But that's the purpose of this, to start to have that conversation, understand what the drivers are. It's one thing to say that you're going to go high on the curve on the spectrum, say on the left-hand side in the upper quadrant on, ratepayer value and certainty, which means maybe you're only going to give distribution deferral value. But on the other hand, there's no customer provider value. So you're not going to get the response that you think you need. So there's a balance there that needs to be struck to figure out how you get to that upper level where you can get sufficient service quality and reliability at the same time, compensation that is sufficient for somebody to participate.
Can I make an observation? So I think, so this is kind of a topic to me of what's the transparency of the value, right? Who is getting, what is the transaction that gets you the benefit for the cost that's coming about? And that seems really closely tied with earlier work you've done, Paul, with regard to DSOs and the whole structure of the industry. I mean, how do you, to get these values, you have to, I think, look at them from who's operating the grid at the transmission level and distribution level, who has the responsibility for the wires themselves and the maintenance of those things. And you have to kind of, if you're going to get the transparency of the values, you can't do it as one big box. You've got to start breaking those boxes, decomposing it, and then seeing the places where the transactions and those value streams become more obvious and transparent.
And that's been happening, Steve. So, through the integrated distribution system planning that 20 some states now have adopted and are pursuing, there's much more detail around, in the distribution planning around grid constraints and the nature of the constraints and the grid needs and the locations. And as a result, much more transparency around, what the cost implications of that is and the like. So, I mean, we're not all the way there, but we're further down the road in terms of understanding what the cost implication is and the specific locales and the nature of the constraints and therefore, at least, and in many cases in the newer approaches that people are looking at, that may set a cap on the market. But again, to the points that folks were making, that's just one dimension. There may be other elements that come in that sort of set the cap, and then the competitive market in some of the newer approaches that'll touch on, like local flexibility markets, the distributed capacity procurement, and so on, have then the market basically on the prices, the offers submitted set the price. But again, where the cap is set is that's a whole question that was raised a moment ago. Yeah, I think Mark, you raised your hand.
Just to key off of that thought, I appreciate how this shows that the benefits are not the same from the utility and the customer in this chart. And I don't think people recognize that if we're optimizing some constraints and parameters and values for one entity, it doesn't mean that we have, it implies that there's a trickle down economics effect, that if we optimize the system, that it's good for the customer. And my point is that a few slides back, we've been doing that for 20 years and it has not benefited the customer. So what's going to change?
Yeah, those are the open questions that we explore in terms of, so how are the different ways to approach this? How do we animate those responses? There's more to talk about here, but points are well taken, and that's part of the discussion that's ongoing, right? In terms of how do we crack the nut in terms of getting the kind of response from behind the meter and potentially front of the meter resources, distributed resources to be able to address these issues. Somebody else raise their hand?
Yeah, Sean.
Yes, this is Sean Chandler. Thank you. Just a question, Paul, about the NEM tariff and net energy metering with some of the utilities I work with in California, and having been to at least a few discussions about service quality versus compensation to participate, I was a little surprised to find that is the highest customer value proposition. Many customers, at least in the meetings, in the rooms that I'm in, customers tend to complain about the amount that they're compensated on the net energy side. Certainly there was a grandfathered condition that has just been recently placed in California, where there was more flexibility before to pay more, and now it's more fixed. But I'm just curious on your thoughts on that. does NEM, are customers really, based on your research, do you feel that customers are feeling that they're adequately compensated for DSM programs? I think that the certainty in how they participate is certainly the strongest under net energy metering and demand side management programs, because it's black and white. But because we're conflating the value and the certainty, I'm curious in your thoughts on that. Thank you.
So the value and certainty in terms of compensation, or what the customer sees in terms of value, and or the service provider sees in value, is what the horizontal is. And the NEM here is not the California NEM 3.0, right? This is the original NEM. And I don't think anybody really had any issues with the original NEM in terms of the,
I agree with
value.
you on that. It was much more accepted, right. Certainly, right?
Right. And that's what this is referring to, is like the original NEM type tariffs in many places. And it wasn't just specifically California, but I mean, there were incentives built in to, spur adoption. And the certainty was that you were grandfathered for 20 years or whatever the life of the investment. So it was pretty certain. Same thing with DSM program. And when I say traditional, I'm talking about deemed savings type, energy efficiency programs, and some of the demand response programs that didn't have any sort of pay for performance dimension for the service provider or for the customer, right? So again, pretty certain, and the value was sufficient for them to participate at whatever level they participated, but and they had participation in those programs comparatively. So that's what that was to referring to. And retail TOU is a general concept there. Folks are looking at that time of use. And again, we know on TOU rates, we've had relatively, modest adoption of those by customers, and partly because it's not clear they see the value in it. It's not real clear that they are actually going to benefit, depending on how their consumption is, and whether they're paying attention to changing their consumption to align with the time of use. So that's why that's there. Obviously, the fact that there's time differentiation does give you a little bit more alignment with what the grid need might be. So there's some things there. So that's why that one's there. But and certainly, if folks are interested, offline I could go into it more. And in the paper we do discuss it. This is the paper that was released earlier at the beginning of this year. That's on the DOE website. Next slide, please.
Thank you, Paul.
Thanks for the question.
Ron has a question real quick.
Hey, Paul, I've been sitting here pondering sort of a similar analysis that one might look at, showing the tension or the interplay between the bulk power system and the distribution system, which you mentioned a couple of slides ago. But it seems like there may be a similar kind of a discussion about, benefit, value, and conflict between those two, with a similar sort of view. Have you done anything around that?
Sorry, between bulk system and distribution,
the bulk system and the distribution systems, where you could think of the distribution system, of course, as the customer of the bulk system, and
right.
Maybe conflicts in terms of who does what for what benefit and what purpose.
Yeah, that's part of the analysis that I was mentioning, that a couple of utilities that I know of, there's a few that are examining that in more detail right now, doing studies, bottom-up studies to look at that. And then that's part of the analysis that's going on in New York with the grid of the future. There's a sense by the regulatory staff in NYSERDA that, the edge value is, should be, we should think, I don't want to speak for them, but there is a thought out there that we need to start with the distribution value first, because it tends to, when we look at the projections in terms of cost, that's where the growth in capital expenditures, that's where the rate impacts are. And so if we start solving the distribution first and wholesale second, which has traditionally been the opposite direction, the way that DSM programs have been, and even rate designs have been, which starts with bulk system, and then maybe we think about distribution. And so so there's analysis underway. I think that's an area that I think we'll see more of, or see some results from some of these studies that are getting done. They'll start to show up in some regulatory filings, my guess is, in later this year. And you know, in the New York case, the analysis that's part of the Grid of the Future, where they've got consulting engagements underway to look at some of these questions. And the first set of studies were released, I think, just in the last couple of months for phase 1 and 2, and then phase 3 is underway. There's a new consulting engagement underway to look at that. So I think we'll see more results in the next year or two coming from that. So, and hopefully, it's one of the areas that we're looking to, you know, expand into with the you know, the next phase of work for OE in conjunction with PNNL with Jamie and Chris, that we're hoping to get started here pretty soon.
Thanks.
Yeah. One of the other things that that we were looking at and thinking about was the incremental ratepayer cost for different sourcing methods. So, you know, obviously, as we talked about a moment ago, we need to understand what sourcing methods are more effective in terms of attracting participation, and compensation goes into it, but also the other, you know, aspects of that sourcing method, whether there's contractual requirements, what the tariff may or may not require in terms of terms and conditions and programs and rates and so on, or flexibility market mechanisms. But the other is what's the cost of ratepayers in terms of these various, you know, the incremental cost, if you will. So if we think about, you know, retail rates, whether it's a time varying rate or DER rate, like what New York's VEDR, for example, those have relatively low cost for billing changes and customer communication. So that's not really going to have much of an impact on customer rates in terms of potentially increasing costs. Demand flexibility programs, if we start to shift those from being very focused on bulk system to more geo-targeted distribution programs, we can probably, you know, just funds that were already authorized could be redirected, and maybe we get more value based on the analysis that we were just touching on, for example, Ron, you know, to look at how do we get maximum value out of those. Obviously, this is a consideration in California, where I think we're spending somewhere in the neighborhood of $1.5 billion a year on DSM programs. So is there a way to get more value out of that with, you know, also looking at redirecting some of it to geo-targeted and temporal needs, including energy efficiency programs. And then, you know, if we think about a VPP standard offer tariff, that was a concept that was introduced last year, is there a way to think about that in a way that could be seen as net neutral to customer rates, which is obviously a big consideration, as I keep mentioning. The procurement bilateral contract costs. I think, again, if we're thinking about standard offers, bilateral flexibility markets, all of these tend to have some incremental cost to ratepayer. Presumably, it's going to be less than what the otherwise applicable, you know, sort of traditional grid investment would be. But in all three of those cases, they're going to be incremental to what the customer had been paying, because you know, there's an increase, but the increase isn't as much as it would have been under the capital investment, is the idea, right? So how do we think about this? And one of the things that we took away is, and what I was highlighting in that sort of portfolio bubble, is that it doesn't seem to us that there's one solution that's going to solve everything, and that because obviously we still have a desire to use, you know, time varying rates, and DER rate are important, and you certainly have these DSM programs, and those will continue for some time, that there's a way to think about mixing these in a portfolio so that you can take advantage of the fact that some of these are essentially very low or no cost, no incremental cost, and then the other elements that may get you higher performance, but have some incremental cost. And so thinking about that from a rate rain impact standpoint is part of what we kind of kicked around and explored in the paper. Next slide, please. Yeah, and this is kind of what this is, I just was talking about in terms of how do we think about evolving. I think to the points that folks were making on the prior slide, that, the existing approaches are really not that great, and we need to think about evolving them and address the issues that are related on the two axes. And realizing that no one solution is going to be, the perfect answer. And so we need to think about a portfolio of approaches that can help us get to what we were trying to accomplish, which is how do we leverage, distributed resources in the value that they may provide. And in this case, kind of very focused on distribution needs, but by extension, the implication on bulk system as well. Next slide, please. This just illustrates that we can take an approach where we think about, a portfolio optimization, not unlike what we do with thinking about, an integrated resource plan, looking at a resource stack. And so how do we take advantage of these various approaches and the related distributed resources that are part of that, and then, create a model portfolio that can address these needs. There's a hand raised.
Yes, Sean?
Yes, thank you so much. Could you go back just one slide? I had a question. Paul, you're saying that I wanted to just highlight on the time of use tariff as it goes up specifically to the EV TOU tariff. I've been working for CPUC over the last 6 months or so on EV specific TOU tariffs. And we're seeing something that's interesting in the distribution grid, that it's incentivizing a separate type of behavior to go ahead and charge at home. And that in itself is creating additional, we'll call it strain, on the distribution grid, which I believe speaks to something you were speaking about earlier in the difference between where the investment needs to be made and, how do we align around that. So I'm interested in your thoughts on that. And then I may have a follow-up. Let's start with that. Thank you, sir.
Yeah, so this is just illustrating that that we need to think about differently. And for time of use rates, we need to think differently about how we get greater adoption and alignment with the needs of the grid and the value for ratepayers in general. EV TOU rates have been much more effective in terms of adoption and performance, if you will, than retail TOU. Now, so there's attributes of that seem to us as interesting. And are there things that we can think about with why EV TOU rates have been so relatively effective, and to adapt and evolve retail TOU rates? And maybe they're a little bit more specific, technology specific, or are there ways to kind of just think about, the experience of the other and that could be used to adapt on the retail TOU? On the second point, I get what you're saying. There sounds like they've been too effective. And so now we need to think about, that implication at the edge and, for service transformers and service connections, and possibly even, metered connections. And, how do we think about, managing that overall, expenditures and the implication for actually trying to address it over some time horizon? Because there's obviously
yes.
a two-year backlog on service transformers, right? So if we're creating problems at that edge, we're going to create a massive problem. So do we need to, change the way that we think about that tariff design such that it doesn't result in the outcome that seems to be trending from what you say?
Yeah, I completely agree. The issue, you might show that that's a flexible move if the EV TOU tariffs are applied ubiquitously across a geographic area. It's the same as you show here for the traditional DSM program versus the geo-targeted DSM program. The idea that using, a machine learning function or some other methods, and obviously I think that we'll be talking about this maybe today and tomorrow, but the idea that if you can't be targeted in the way that TOU is applied in at the distribution edge, and I mean at the circuit level, customer by customer, then you're decreasing the value for the utility ratepayer through the mechanisms that the utility applies to distribute their costs evenly for the capital expenditures themselves. And that distribution, how do we include equity, or how do we show that it's an efficient use of capital to have these TOU programs? Right now, they tend to be targeted. They're obviously targeted towards folks who have EVs, and EVs tend to be distributed unevenly in terms of equity and other demographics. So generally, it could go up like that if it's very carefully applied. But generally, I believe has a downward. It does provide certain customers more value and absolute certainty. Absolutely, it does. So you're going to the right on the x-axis, but on the y-axis, it could end up going down. So just
Yeah.
Thank you, sir.
Yeah, and the paper, we don't get into the details of that you said so eloquently, and very interesting to hear your insights. We didn't get into that. The point was, we know that current retail TOU tariffs are not that effective, and particularly they're not effective for distribution, really. So how do we think about evolving them? And we just used EV TOUs as kind of an example of something that's much more effective, but obviously it sounds like it's too effective and maybe not. It needs evolving too. So yeah, points are well taken and completely understand. Yeah,
much appreciated.
Yeah, and by the way, this is a good example of we have not perfected. This is all a work in progress, right? As we get traction with one thing and we think it's really working well, and then we realize, oh, there's all these other sort of collateral effects, and maybe we hadn't thought about that we need to consider. So we're definitely on this journey, and I think as some of the earlier questions and comments, we're still figuring this out. The purpose of this paper wasn't to say this is the answer, but rather here are some considerations we need to think about as we migrate through this and try and address and improve as we move along. Yeah. Question?
Yeah, I mean, a lot of these things are new. A lot of concepts, as you mentioned, things are evolving. But when it comes to the regulatory side of things, there's a need to build a record, right? That's what they call it in the proceeding. And I'm struggling to find things to put on the record to support this. I would love to crowdsource resources from GWAC and fellows to see what can we introduce to a regulatory proceeding, or what can we study that shows these are the values that DERs provide to the grid, and this is how they avoid capital expenditures, reduce O&M. I know there's a host of topics around that, but I have not seen a study that I think fits the bill for building a regulatory record.
And how to quantify them.
Right.
There's not been any definitive way to quantify those values. It's all anecdotal, and commissions don't want anecdotal evidence.
So I'll give you an example. There's methods to do this, right? You apply an avoided cost calculator against a load shape, something like that. But it's very difficult to do that because there's so many factors, right? I mean, that's an implementation exercise. What we're talking about is a methods exercise, or something that can be cited and sourced that says, for this state or this jurisdiction, we can, avoid this. I know that the Bertel Group has done things like that. We've seen it from, the DSO plus T studies, fantastic, and a lot of stuff coming out of PNL is great. But I can't introduce. Yeah, so I'm wondering if you have insight to that.
Yeah, so I'm going to touch on that in a couple of slides as to an approach we proposed in one of the papers and is being implemented at a couple of utilities right now. So I think it's not the total answer, but it goes in the direction that I think you're addressing, Mark. Next slide, please. So as I mentioned, in addition to sourcing mechanisms, or methods, there are orchestration mechanisms, and this gets a bit to the interoperability discussion and question that we were discussing briefly there, Ron. So if we think about the sourcing methods, we've got pricing, programs, procurements, flexibility markets now, and those feed into orchestration mechanisms. We also have interconnection standards that call out requirements in several cases, several states around autonomous option. And then we sort of look at these orchestration mechanisms in sort of three broad categories: dispatch signal, autonomous, and behavioral. And so when we think about dispatch signal, we have centralized, decentralized. We don't quite have distributed yet, but decentralized. This is kind of the current state. We have obviously price signals that may be used. We have control signals that may be used. The thing that we got to looking at is that we may have direct interface to the device. We might have one level indirect interface if it's aggregator from utility to aggregator to device. We may have two level from utility to aggregator to OEM cloud to device. And at each of those layers, there's a level of interoperability that, and this doesn't show all the applications in between. So, there's protocol translators involved in many cases. You've got between the proprietary OEM API, you've got grid edge DERMS, you've got then the aggregators platform, and then you've got those interfaces with the utility systems, whether they're DERMS and or ADMS or SCADA. So there's a lot of technology layers in between, and so part of this was trying to understand what that might look like, and understand what the issues are in terms of performance, sort of physical performance at this point. So not the financial or regulatory or commercial, but here we're trying to understand what are the physical aspects related to the technologies involved and the parties that are involved in this chain to effectuate the response. In autonomous, we have fixed parametric, where we have preset standards. For example, some of the IEEE 1547 standards settings. We also have preset engineering based. Some of those are tied to this, the flexible connections kinds of approaches that are starting to come into play related to dynamic operating envelopes and the like. And also dynamic parametrics, where you have more periodic engineering updates, again, more towards the DOE dynamic operating envelope, and more dynamic response to grid conditions that may come into play that people are looking at. So, and again, depending on the architecture of how these systems are being implemented, you may have direct interface from, say, the utility to the device. In some cases, like in Australia, where they have, I guess it's a IEEE 1547 AU, which allows the DNSP to directly communicate to the device independent of the OEM's cloud system, so that they can send the dynamic operating envelope parameters or control signals, and then for what the inverter needs to operate. You may have one level where the OEM interface, or you may have two level where there's whoever the operator of the system, they may have a controller that then interfaces with the inverter. And that is more like what California's limited generation profile looks like in terms of the architecture that the commission was in their order. And then behavioral is, classic responsive demand or energy conservation kinds of measures. For example, what California a couple of years ago asked everybody to, conserve 10-15% of their consumption, and people did. Some more brute force and not, sustainable, but there are some behavioral aspects, and certainly responsive demand is one, and conservation is the other. So we looked at these because all of these are potential ways to, kind of somewhat related, but in some cases independent of the sourcing methods, are ways to think about how you're going to effectuate the response from the device itself. Yeah, you sure?
Yeah, this is a very nice diagram that kind of shows the end-to-end process. Before you mentioned that the sourcing methods by themselves are not sufficient and we need portfolio creation. So would that go in between the green boxes and the blue boxes, basically between sourcing methods and DR orchestration, or how do you envision that?
So when we think about overall, how do we want to animate and create a portfolio? We look at we're suggesting we look at both the green and all the elements that go into green that we were talking about previously, and all the discussion that we had around those slides. But also needing to think about if we're thinking about performance, reliable performance, or at least predictable performance, then we need to also understand the blue elements and all the, both from a technology standpoint as well as the entities involved, because some of these really include a lot of complexity. We talked about, at the outset, some of the interoperability challenges. So, when we think about implementation of various orchestration mechanisms, we can start to incur a lot of friction, a lot of cost, potentially, a lot of challenges in terms of reliable performance, and like I said, some cost implications for maintaining this, and also because we've got a lot of emerging technologies that are providing the interfacing technologies to enable this. It's many of those are earlier stage companies that are also going through their own the normal evolution of growth and maybe acquisition or pivoting, and so there's a dynamic in there to also understand that this is going to evolve. When we think about something over a 5 or 10-year horizon, that technology landscape is evolving at the same time as we're, as you think about the implementation of these various orchestration mechanisms. So all of this needs to be, considered at some level when we think about reliable use of distribution. And again, because at distribution, we're talking about very locational based needs, there, as we understand this, the reliability level needs to be pretty high. And, if we're going to basically avoid distribution expenditures, then, the level of reliability and performance needs to be, fairly commensurate with what the typical distribution reliability is, which is on average in the US is 99.86%, according to EIA. So it's pretty high level performance that's going to be required when we think about this. Again, we're thinking there's a portfolio, so it's not just one, and we're not going to take one track and just look at one mechanism, but you're going to need to think about how you, as you put this portfolio together, what the implication is on the orchestration mechanisms. Both, is it manageable? Two, can you achieve the reliability that you're looking for on a predictable basis? Next slide, please. So this gets to the kind of techno-econometric model, and the paper that's in the Evolution of Sourcing Distribution Grid Services paper, we explained what this model is and this approach. And this is something that we developed in conjunction with talking with Jamie and his colleagues and Jim Ogle and folks about how do we think about kind of first assessing the sourcing methods and the orchestration mechanisms and looking at the applicability in relation to what the specific grid need and the specific grid service that's providing, trying to understand the risk factors and any adjustments that's necessary there to kind of understand how we need to adjust that. And we sort of look at that from a reliability screen for the solutions. And then we get into this engineering economic analysis and the cost and benefits. Now, the benefit side is what folks are talking about, and in terms of what is the value stack that distribution plus anything else, and particularly as it relates to wholesale, but other values that may be important to incorporate. That in box 7 is where that analysis gets done. So the first is we're looking at performance and alignment to the need, and then the second is we start to look at benefits, and then as relates to the sourcing methods, how those can come into play, and then we look at tie that into an overall engineering economic analysis. The bubble underneath it is where we started to introduce the idea that as part of this risk analysis, we need to start thinking about the equivalent of an operating reserve on distribution. I mean, one of the problems with NW, non-wires alternative procurements is they were a one-to-one solution, so that, if there was a need for a megawatt, the procurement for that by the utility was only for 1 megawatt. Well, that doesn't account for the fact that there may be issues, and therefore you may not get all that you need. And as we move into different structures beyond just those, kind of very simple procurements and into things like flexibility markets, in the UK, there's a recognition that probably need to buy a little bit more just in case there's not, 100% performance. And so as a result, to manage some of that risk, you can start to look at using Monte Carlo analysis to start to assess the amount of headroom that you might need in terms of reserve margin to buy a little more service from the marketplace to cover potential aspects of underperformance, if you will. So, and yet still maintain the reliability that you need from an operating standpoint. So we've introduced the concept of how we could approach that in this context. Because as you know, in distribution, we don't have operating reserves, unlike bulk system, that if there's not performance, they just dial up other resources that they have under available or do an out-of-market dispatch to get the resource in. We don't have that at distribution and under most of the existing approaches that have been used over the last 10 years. So here we're trying to introduce a similar concept. It's a bit different in terms of the analysis, but trying to address this need. And then, obviously we circle back to look at a feedback loop in terms of how the performances work, and then sort of feed that back into the risk analysis. So this model is one that I'm aware of is being a similar approach is being used at a couple of fairly large utilities right now to try and understand this. And this is part of the discussion that I've been sharing with the New York Commission and NYSERDA in terms of the kind of analysis that the staff is thinking about, ultimately trying to help inform their approach to more, utilizing more distributed resources and the like. This is still early stage, but this is kind of the approach we're thinking about. And many of the tools that to do this analysis already exist. It's a question of sort of more, thinking about the process by which we would, link these various dimensions together to yield an effective outcome. Any questions on this? Okay, next slide. Now switching gears to operational coordination. So that's, so where we're leaving off is, okay, we're trying to advance how we think about sourcing, how we think about the orchestration of these resources to utilize them for distribution. Again, very focused on distribution here. And then also how do we evaluate them, create a portfolio, and how do we do it in a way and thinking about both in terms of optimizing the ratepayer benefit, also, understanding the value that, is necessary for participants to provide those services, and also address the reliability needs of the utility in terms of their the grid performance. So, within that context, now we're sort of moving into, okay, assuming we have this large pursuit across the U.S. as illustrated in the map earlier, that you have a lot of utilities pursuing on some dimension or another the use of distributed resources. How do we think about coordinating those with the bulk power system? And also the fact that, you've got service providers and of various types, and you've got customers that in many cases we're talking about customer-owned distributed resources or customer energy resources that are in play, and the customers themselves have particular needs. I mean, I certainly have my own need for my battery. It's about resilience, and I'm not really selling services into the system because of the 10 outages I had last year. So I want to make sure I've got all the consumption energy available to manage the consumption that I have, even when there's outages. So so we know that people have their own particular interests in what, that they bought these resources. So, we need to take that into account. Next slide, please. So as we think about this coordination, and particularly as we think about, I'll set aside customer for the moment, although that's obviously very important. When we think about the service provider, the distribution system operator, distribution network operator, and the transmission system operator, ISO, RTO, or balancing authority in a particular area that might be, sourcing services. And there's really three fundamental dimensions, and these are called out in the FERC 2022, but these are really the fundamental three elements that are needed for coordination. One is the DER registration. So there's a need to have an understanding of what DER are going to be participating, both individual and aggregated DERs, and whether they're going to participate in wholesale for retail programs or tariffs, and any distribution grid services that they may be providing, or any combination of those, so that to the extent that folks, there's a clear understanding of which ones are going to be participatory, and understanding what they are, where they're located, and the like. That way, everybody has a clear understanding of those participating resources. We also need to have, sorry, yeah, Ron?
Real quick, on the non-discriminatory participation of DERs, I want to understand that a little bit better, because when certain DERs has certain characteristics of what they can and cannot capable of, and in certain areas where they are to be a part, if they want to be a part of the market, if they can't offer in any useful services to the utility, then there's got to be some restrictions saying, no, you don't get to participate in that because you don't have the capability to do the service we need. And so I'm trying to understand that clarification.
Yeah, so the use of the term non-discriminatory here was meant to mean that the non-discriminatory in the context of what the utility may have in terms of their programs versus what a third party might want to participate in, and making sure that the utility is not taking discriminatory action against third party DER participating in markets versus their own programs. And that non-discriminatory participation means that you're treating all qualified DER, which is done in the registration process, that they are that they can participate effectively, and there are no impediments due to discriminatory action by the utility. Does that help?
Yes, thank you.
Yeah, and I'll explain a little further on that in a couple slides. And then operational coordination is obviously, in day ahead and real time, making sure that there's an understanding of what the dynamics on the system, to the extent that there's changes that the aggregator may have in terms of the capacity available or the service delivery. They may have derates or even curtailments that they need to initiate for. I mean, they could have technology challenges that mean that the aggregation is no longer accessible. So they would need to communicate that to whoever they're providing services to. The distribution system operator needs to be able to communicate if they've got outages that may impact an aggregation that's providing service in the transmission system. And likewise, if there are changes on the transmission system and the way that the aggregation is being used, that they should be communicating that to the DSO, so the DSO understands that there may be load changes, net load changes on their distribution system that may be meaningful to understand in the context of switching or just other loading considerations. So I think that's well understood, and there's been a lot of good work that the labs, PNNL, EPRI, and others have done in terms, and obviously there's a lot of this work going on now for the implementation of FERC 2022. And I'm just calling out here that these are sort of fundamentals, and we see this not only in the U.S., but this is also very much the same as the U.K. Is looking at the same and implementing similar sort of approaches to deal with these, three fundamental areas. And the same thing's going on in Australia. There's a recognition under Project Edge that, there's a similar need to address these sort of three fundamentals. Yeah, Yashar.
There's also a requirement to perform impact study of the aggregated DERs. Does that fall under any of the three pillars that you include here, or is that a different work stream?
Yeah, so that would be either under registration or market participation coordination. In the paper we have it bucketed in one of the categories. For here, I tried to just make it more general and not get into that, because what I'm getting at here is that these are the three that in the U.S., but these are also applicable and being pursued in the U.K. and Australia. So this is there's a global recognition that these three elements are sort of fundamental.
Thank you.
But the registration in terms of eligibility to for particular services and the like, as Ron Cunningham was mentioning, that's also part of this. In the FERC case, it's a 60-day review, essentially for deliverability, but it also is part of the review for looking at whether there's there's no conflict between other programs that they may already be participating in or services that are already providing, so that there's no double counting or the like as part of any potential market participation. So there's that whole qualification process includes both the parts that you were mentioning, Ron, and also what Yashir was mentioning in terms of physical deliverability. They don't call it deliverability, but it's essentially akin to that.
So
Any?
I have a question, Paul, to Steve. What have you considered? So this matches very well with the model for doing some interoperability or interactions between two parties, but maybe the step that's missing would be at the end, both the ability to monitor and to assure that the operation was done properly, and then to settle that.
Yeah, that's all part of the. You'll see this in later. I'm just calling out sort of general categories of when we think about coordination, but this isn't all about the whole life cycle from sourcing the service all the way to settlement and the like. This is just saying when we start to think about coordination between the various entities in terms of their market participation and operational coordination, these are three fundamentals, areas. But yeah, you'll see in other slides. Yes, it goes. You need to think about the whole settlement process and how those would get reconciled too. This doesn't try and capture that. I've got 5 pages of requirements, and Jamie and his team have expanded on that in greater detail. So there's a lot more detail to what's required. This is very high level.
Just to maybe elaborate on that a little bit, what Paul and others have been looking at is the kind of the requirements for the functions that facilitate these types of interactions. And we're looking at dissecting those functions down to the interoperability requirements for each one, and hopefully make it jurisdictionally flexible, because who owns the different platforms for these things varies, right? So looking at the functions, the inputs and outputs, and then how they tie to the other functions, and then the rules can kind of follow those functional capabilities.
Right. It's just that when you think of the settlement and how you're going to monitor and test it, that ends up kind of implicating the register, all these other functions as well. So to me, it's very principal category, if you will.
Yeah, it's a sub part of one of of these, particularly in the market coordination part, and the paper that's listed there that that myself and Salma Patel at ICF and Dave Kathan, I think you all know, or many of you know, was at FERC and helped write FERC 2022. So we put together these, as Jamie said, it's a capabilities and high level business functionality outline. And in the appendix is actually, line item notes where in FERC 2022 is called out the kind of functional capabilities that are required. Now, what Jamie and his team are doing, as he said, is taking those and going further. But yeah, settlement is a key part of it. We also sort of highlight in a diagram, I think might be on the next slide, that gets at what you're describing. So if you look, for example, and again, this is very high level. This is not intended to be any sort of architecture, but you've got these three broad categories of capabilities as mentioned: registry, coordination, market coordination, operational coordination. In every one of these buckets, you've got some sort of settlement function. You can see in the DSO, they have a settlement function. You can see in the customer, they have, telemetry data or other, other telemetry. And of course, they have their own systems for dealing with the commercial terms and settlement. And then, of course, in the TSO, they have their real-time telemetry and they have their settlement system, which is on the bottom. So yeah, very much, that's understood and recognized the role that all plays in terms of closing the loop on how the performance works and compensation, obviously. And again, this was really just intended. We put this together. The first version of this actually was created about 6 years ago for the province of Ontario for IESO as part of looking at how they would need to think about coordination and the various elements as they would move forward and think about the various, DNOs that they have there, which is a roughly 50 some distribution utilities in Ontario, and how the Ontario ISO would need to interface and how that might look and what are the elements that they would need to think about and the kind of technology platform capabilities that might need to be developed or sourced to be able to support that coordination across all those different entities, and of course the aggregators themselves and the various service providers that might be involved in the various utility efforts, as well as what the ISO Ontario ISO was going to pursue. We've updated it in line with the for 2022 in the paper. But again, Jamie's going in more detail, and frankly, at this point, this is illustrative, but there's much more detail going on in the actual implementations around the country for the various states. And for example, New York is developing their own DER registry. I think there's some discussion in California about that too. But in other cases, they're looking at sourcing, commercial platforms to do some of these functions. Next slide, please. So what I wanted to shift into is, okay, so that's where we're, kind of heading with for 2022, like coordination. But when we start to think about some of these new sourcing methods, like these flexibility platforms, flexibility markets that really developed in Europe and are starting to migrate into the US. For example, PICLO has a project with Connecticut for both Eversource and United Illuminating to create this more of a little more, it's a forward market, but which with different time dimensions and some other elements in it. I haven't finished digging into all of it to be able to get into much detail about how it all works, but how it's being implemented in other systems. There's definitely an opportunity with some of these platforms as they're being implemented in Europe to basically use the same platform for the wholesale market operator to source services from DER as the distribution operator sources services. So not having to go to two different interfaces. So one where you've got utilities using one approach to source through some sort of marketplace, forward market, versus what the ISO does. So in the case, they're people are looking at, well, like, can I use the same platform to support both? And that's really what's being reflected here. Maybe this is an opportunity to create a little more efficiency, reduce some of the transaction costs for service providers. In this case, DER aggregators. That's what DERA stands for. And so, this could potentially, resolve some of this.
Paul, just to let you know, Chris has a 45-minute departure time. So if we want to pause, or if you have just a few slides left, I'll just let you make that decision.
Yeah, I just have, I think I had, yeah. So this, I'm just going to say there's some references here you might want to take a look at that. I think not only are we looking at the technical aspects and some of these other issues, we've also been looking at business issues, business process, and things like contracts and codes of conduct. One of the things that I know has been starting to become more of a discussion around this non-discriminatory efforts and trying to make sure that utilities are non-discriminatory is we have produced a paper outlining what the elements of a distribution standard of conduct, similar to the FERC's transmission standard of conduct, to sort of separate the distribution operation function from the sort of the marketing function or the customer programs and services function, so that you can have much more of a arm's length role there, so that it can address some of the concerns. And some utilities are starting to talk about that. For example, in California, a couple of utilities have offered that they may be open to adopting something like a standard of conduct for distribution. Next slide. And this is just pointing that out, and we can come back to this. And then I think the last slide. Oh, just that, as we move more into this so a lot of what we've been doing is kind of, the path we've been on for a while. But, as we may start to see more of an AI-driven autonomous system, then the question is, some of the mechanisms and the approaches we've been thinking about might be upended or substantially, change the way we may need to think about things. And I don't know that we've really put a lot of thought into that yet in terms of what the coordination structure would look like if we have much more autonomous, automated, and distributed system than the sort of very much, human-centric, sort of human, technocentric kind of approach we've been working on, and a lot of what I just shared in terms of the way that FERC has approached it, and we're seeing in other parts of the world. And the last slide is just teed up as this point. The paper that Lorenzo and I produced in 2015 is now 10 years old. It's actually just a little over 10 years old. This presentation that this came from was in March of 2015. And I'm not sure we've really made, substantive changes in terms of the thinking here. We've kind of done variations on the hybrid theme, but it's not clear to me that this line of thinking gonna get us to where we need to be in, 10 years from now. So, and again, how automation, how autonomous functions may develop, what does this really look like, and address some of the other concerns that the folks raised earlier on in the presentation. So this was really just kind of a challenge slide to the group. We're not going to have the answer today, but how do we need to think? Do we need to think differently? What is, are we on the right path, or do we need to go in a different approach? Thanks.
Paul, thank you so much for joining the team and so on. I guess they've done a ton of great work. So, and hopefully we'll keep it moving forward.
Thanks, Paul, for your great presentation. For more information about the GridWise Architecture Council, please see our website at gridwiseac.org. And don't forget to subscribe to our YouTube channel at the site listed. Thank you.